All right. I was muted too. How about that? So, what I was saying is that I have a screen typically right here, so I can look right at the camera and also see what I've got going on. Well, that screen died last night. So, I am excited to see a new one come in. So, if you see me looking around, that is why is we're going to I'll be looking off to some of the other screens so I know where I am going. So thanks for joining. I don't know how the weather is around where you guys are, but it is a nasty rainy day here. And I think it's a good day to talk about some 3D printing. So, what is the big deal? Well, I really didn't know. I heard a lot about the Bambu Labs printer, and I never really seen one in action. And I was like, you know what? This A1 is out. It's like $400, 500 and some dollars if you get the four color thing and all that. And I was like, you know what? I'm gonna just try one. I was a little bit skeptical just because the build volume is so small compared to all the other stuff that I use. But what was interesting is, I mean, right out of the box, I was able to get the printer up and going. It did a bunch of like 15 minutes of setup such. I quick did a benchy. The benchy, literally including the heating, took like 21 minutes, came out flawless with year-old PLA because that's all I had at the time. And then I just had a socket and I had to scale it down, but I just wanted to see what it looked like. And again, the socket just turned out gorgeous. So for that price point, and when I took calipers to this thing, it was spot on. And I was like, man, for that price point, how can we get around some of the design constraints of 256 millimeters cubed, essentially? Most of our prostheses, especially once you add a locking mechanism, are going to be taller than that. And I kind of wanted to use it anyway. So I haven't printed anything, or I haven't printed the double two-piece socket, but I wanted to show you kind of what I'm up to and what I'm thinking. So again, I've just been thinking through some of this. I literally got the printer set up on Friday, ran a couple things, Thursday, sorry. Ran a couple things. You probably saw them on LinkedIn, and then we'll go from there. So I am going to put me smaller and move me over here. So we're still working through my setup here. So this is Oqton Freeform, and this is what I choose to design in. It's just so versatile. I just got tired of being in and out of programs that had to test to see if you had a subscription or what have you to the cloud, and Freeform just does everything for me and does it so elegantly and beautifully as well. So today we're just going to do a prosthesis with a bulldog lock, and I'm going to show you kind of my thought process. I actually haven't thought a lot about it other than this is something that I want to do, so I'll probably make a few mistakes along the way. You can laugh and such along the way, and then go from there. Hey, Rebecca. Yeah, man, ZBrush is pretty slick. It's there's a lot of it's very, very powerful, and there's a lot of good things going for it, and a lot of it happens in the orthotic and prosthetic industry. There's a couple things that I just really like with the freeform side of things, but a lot of it can be achieved in ZBrush for sure. So, and there's some incredible artists out there, and I'm sure you are one of them as well. So if you have any questions, definitely put something into the chat and I will pick it up as well. All right. So when you bring in something into Freeform, you're going to have a mesh, something like this. Now, this is not my model, so this is about the socket design, not about prosthetic appropriateness for the patient or what have you. So what happens is that you get something like this in. This is just a mesh. You can see all the triangles really nice and tight here. But instead of triangles, we're actually going to move this to voxels. So we're going to copy this to clay. And I use a clay coarseness of 1.5 millimeters starting off. And you can see just by changing it to clay, pretty much all those triangles almost disappear. So let's see if we can, it's still kind of got this oatmeal-y look to it. But what we can do is smooth that up real quick. So we're just going to smooth it. Smooth one time looks good. Smooth twice. That looks real good. So I'm happy with that. And we can look and see what that actually did to our mesh. And it just took some of the high spots, low spots out. And if you feel like it took too much, you're always welcome to bump that out a little bit. But what I've found is you're really in the ballpark if you hit smooth just a couple times to take some of those highs and low spots off. All right. So what is next? We have this. So I brought in the Bambu printer, and you know that when we have the locking mechanism on, this is a short BK. I'm going to actually take this down here. So we're going to make sure that the lock is in it. So we're going to just take the box down past these pins. So you can see that we're almost all the way in, but there's a little bit at the top here. And for a short BK, you may just lower the ears and try to run it full length, but you've got some options as far as splitting. So what do? We know, and we'll just take a look through here. This is the socket, so this is what it will look like on the printer. So what I want to do is actually just create two pieces, and we'll stick them together like a PVC pipe. There's a myriad of ways to do it, and just a couple things that come to my mind are throwing down a few planes first. So I'm going to hit F5, which goes to my top view. I put a plane here, and I'll put that plane roughly half. So just remember, and I forget which guy, which there's some research out there that essentially shows that the distal end, the last 3 inches of the socket, takes the most force. So we need to make sure that this area is not only very strong, but nice and solid. So I try to keep that joint outside of this area. And again, I used to do this a lot when we didn't have higher build volume sockets. I used to split it, but I've actually gotten better at design. And so there's some things that I would do different just to make it look a little bit cleaner and keep the strength. All right, so we've got one plane down. I'm going to actually drop another plane. I'm just going to duplicate this, and we're going to move that plane. We'll edit that, and we're going to move that plane down 20 millimeters. So that would be 115 roughly. We'll say 110. Yeah. So let's see what we can do here. So I'm going to go ahead and duplicate this one, and I'm going to put the trim lines on this particular socket. So as you're watching my haptic device, this is me putting down the points, and I'm actually feeling the model underneath the socket itself. So here we go. And I'll print this. I actually haven't printed it yet. I'll print what I do from this. I'll print it. So the neat thing about Freeform is you can roughly put your trim lines down, and these are right on the mesh or the clay themselves. And then you can go back and say, does all that look pretty good? And for the purpose of this, I might just move some of this around here. Again, this is not about appropriateness or clinical relevance or anything. This is about socket design. So again, if you have any questions, you can drop them in the chat here. Let's see if anything else is in. Okay. So I'm happy with that. So what I'm going to do is I'm going to call this cut. So it's always good to label your stuff. And so I'm going to duplicate this, and we're going to call this socket 1. All right. So what am I going to do now? I'm going to go ahead and offset my socket, and we're going to go for a thickness of 4 millimeters. Okay. All right. I feel pretty good about that. So this socket is a right socket. So the locking mechanism typically is going to go to the left. So we're going to actually reposition that. And we're going to go 180 degrees. Rotate Y, 180. Okay. So we've got the lock going to the medial side. That's perfect. I have this little piece down here. The neat thing is I'm able to pull curve networks from my step files in Freeform as well, which is pretty slick. And then actually while I'm at it, I'm going to duplicate this one and edit this. And we're going to bring this down. This is going to be for our loft. So I'm going to take a Boolean intersect of this part here. And I'm going to loft from here to there. So, and I'm going to combine that together. Okay, so we've got our socket really coming along nicely. I'm just going to smooth this in. Now, what's crazy is I typically never did this because I was typically working with high flow stuff. So your little transitions or whatever wouldn't show up. But now the Bambu prints literally everything. So we're going to just smooth that out real nice. And why do I like a loft? The loft is important. There's a lot of strength in the straight line that goes down. A lot of people will do something that has a reverse curve in, and you've got to remember that the distal tooth or distal third of the socket needs to be the strongest. And what I've found is the loft is definitely the strongest when it comes to that. So, all right, now we've got our socket done. This is where things will get interesting. So I'm not exactly sure how I'm going to do this. So let me think about it real quick. Okay. Let's see. Okay, so maybe what I'll do. Okay, we're going to go this way, and who knows if it'll work or not. So I'm going to take this and duplicate this, and we'll call this the proximal. So I know you guys are waiting for a crash and burn. Let's see if we can give you what you. So what I'm going to do is I'm going to take this, and that gives me an intersect curve here. So we've got 4 millimeters to play with. So what I'm going to do is, I'm going to emboss here. Again, I'm just kind of flying by the seat of my pants on just what am I going to do. So I do not know, but we're going to try this. And I'm going to do an ease in, ease out. We're going to go down 2 millimeters and do something like that. Okay. So that looks good. That's what I want to do. However, it's not the resolution that I want to be at. So I'm going to actually change the resolution to 0.45. So we'll essentially get 3 times better resolution right now. So now we're going to do the same thing. We're going to do this 2 millimeters. Oops, wrong way. There you go. 2 millimeters. Here we go. 3rd time's the charm. Okay. So I'm happy with that. And the reason why I did this kind of ease in, ease out is just so I can get this little bit of a lip, so I don't have as much of um, uh, an overhang when I'm printing this. So let's bring our planes back in. Okay, let's see. How am I going to do this? Okay. All right. I'm going to cut the proximal section off. I think this is what I want to do. So we're going to use the plane and we're going to cut. We want to separate that piece. Okay, so now we've got this. Okay, this will work. We've got this plug fit going. So now let's do this to the distal end. We'll duplicate this and we'll call this one distal. Okay, so now we're going to take the proximal from the distal, Boolean, remove from. Oh, we need a better resolution. So let's go hit the resolution here. We'll say 0.45. Okay, and so we're going to take the proximal, Boolean, remove from the distal section. All right, so let's take a look at what we've got here. Okay, so we've got kind of that overhang there. Now let's take our cut, Boolean, remove from the distal section. We're getting closer. Oh yeah, that's looking good. So now we've got this nice rim right here where everything will interact with. And so this one, we're going to Boolean, remove from distal. Okay, so we have that distal plug fit set. So let's go ahead and just finish that up. So we're going to go Clay Utilities. So we're just going to, we're making this a little bit more better resolution here. Okay, so that looks really, really good. So we are done with the bottom section. So now let's do the top. Let's see where we're at. The top. All right, so I typically want to give a little bit of tolerance. So what I'll do is I will actually take this and I'll do like a 0.1 millimeter tolerance. And that allows me to put any adhesives in or anything like that. So let's do that. Okay. So now we've got this proximal, but we can take the cut, Boolean, remove from. Oops. You can't cut away something when you have the active. So Boolean, remove from proximal. Boom. So we've got that. That's looking pretty good. So let's put this down to fine. Okay. So I'm really liking what I'm seeing here. All right. So the last thing is, you see how this kind of not super happy with that edge, the way that it turned out. And it's really because of the way that I started off with a much more coarse volume. So I wasn't the smartest about that. But we're going to do a little freeform magic, which allows us to take this curve and select it. And we'll press smooth. Smooth it one more time. All right. Pretty happy with that. So we're finished. We have our distal section. We have our proximal section. That joint is up out of the, the harder area. And you're able to print your test socket, potentially more on your Bambu printer. You definitely, let's take a look at the dimensions here. So you're definitely going to get both of those in there, no problem. So you're talking probably about a 3.5 hour print here and about the same. So, if you had two machines running at the same time, you'd have a socket in about 3.5 hours. And I think that's pretty good with a 0.4 millimeter nozzle. I think that is excellent. So let's just take a look at the cross section here. We're going to turn this one off and see what we've got. So I'm really happy with this. So you can see I've got a little bit of space right here just for some adhesive. So I'll either use some like Coyote adhesive or maybe even just some CA super glue. And you just have this really nice fitting piece, and we'll see how it goes. So I'm super pleased with this. So with that, let's take this off and let's just see. I'm gonna clay course. I'm gonna copy this to mesh and let's put it onto the Bambu printer and just see how long it's going to be. And we're going to do the distal as well. Clay utilities, copy to mesh. I'm going to actually reduce this. So we're going to make it 25% of the density that it currently is. It takes just a chunk of time, but it will help with the Bambu side of thing. It's still going. And what is neat is that I can actually export as a 3MF file, and the Bambu will open that up really nicely. So it'll be a smaller file anyway, and then we'll kind of go from there. So we've just reduced it. So distal mesh. So I've got to change, just bear with me just a second. Um, Export. I'm going to put this, so just hang in there with me. So Bulldog pistol. I didn't want to show you my whole tree here, and reduce that. Yeah, so I have got a ton of files in my file tree, and so I just didn't want to show you that. So, but let's get back to the Bambu stuff. All right, so we're in Bambu, and let's, oh, let me, one more time, sorry. I got to bring that in. So, downloads. Okay, so we're in the Bambu printer, and we're going to see how it'll put it on there. Yeah, so there you go. So let's just see. So I use the draft with a first layer height of 2 millimeters, and we're just going to slice this and see what it says, how long it will be to print. Prepare time, model printing time. So total time 3.5 hours. Okay. So let me get back and we'll take a look and see how long the proximal will take. So we're going to delete this. I'm going to prepare, delete that. And we're going to bring in that other file. All right. So let's see what it'll do here. Okay. And so let's see what that slice, what it says, how long it will take for that. Model time. So 2 hours and 44 minutes. So total time of 2 hours and 49 minutes. So, a combined time of roughly, what is that, 6 hours with a 0.4 millimeter nozzle for a 4 millimeter socket. It's not terrible. And if you had two of these machines running, that would be moving right along. And again, these are all, like, I haven't gotten into all the stuff. Now, I would suggest doing PETG. I am getting some PETG, but I don't have any here because we typically use high flow 2.85 millimeter filament, and so that will not go in the Bambu. So I'm actually getting some of the Bambu high flow 1.75 just to see how that goes as well. Seems to be cost effective, and let's see how much. So 137 grams. So you're looking. These are 1 kilogram spools. So you're looking at probably getting 2.5 to 3 sockets per spool, which is pretty good when you're talking about a spool is going to run you somewhere in the $20 to $25 range. So I hope this helps you out and just gets you thinking around what can you do with this printer, that is it's a great printer and it will give you the outputs. What can you do with it to make it work for you? That you have a massive incentive to work with the Bambu Labs printer, at a price point of $450. When you're talking a test socket's, going to run you less than $10 in material off this machine. So I would definitely highly recommend just thinking about it. And if you need some help, you want some direction, you want to know a little bit more about Freeform, feel free to reach out to me, uh, DM me on LinkedIn, uh, and we're happy to help you. We are a reseller of Oqton Freeform, which is the design software you just saw me use. And I tell you what, it saves time. There's an expense up front, but it just saves you so much time on the development of these side of things. And then you can head towards automation, which I love. So Happy New Year to you. Thanks for hanging in there with me all the way to the end. I'm going to print this socket and see where it ends up, and I will keep you posted on that. So take care. Thank you so much for hanging in there.